Welcome to our segment for today, where we'll be looking at the topic flowcharts and programming languages. We'll first take flowcharts. The flowchart or flow diagram is a graphical or pictorial representation of a step-by-step procedure of solving a computer program in order to create an output. Sometimes you need to do some programming activities and you need to plan it before you start writing your program code. A flowchart is that diagram you need to organize your program. This means that flowcharts are very useful tools in computer programming operations. What are these operations that you can carry out? It may be arithmetic operations that will involve some mathematical calculations like addition, subtractions, divisions. You may want to do a program to add two numbers. You may want to do a program to calculate the average of numbers. It may have to do with your organizational operations. Let's take an instance, FGC Port Harcourt wants to prepare a program that will take care of students' result sheets. It can also be a personal project. Probably you want to do a program that will help you play games. You want to do a program that can help you do your study. All these are some programming operations that can be carried out by individuals or corporate organizations and achieve their aim, just like one needs to plan for every event. Flowcharts or flow diagrams will help you to do your planning. Flowcharts use special shapes to represent different types of actions in a program. What are these actions? You may have the action to make an input. You may have the action to carry out a process. You may have the action to do your storage either in your internal memory or your external memory. You may have an action to send out your output. These shapes are called flowchart symbols. I take it again, the shapes that will help you to prepare your flowchart are called flowchart symbols. These symbols use lines and arrows to show the sequence of the steps and the relationships among them. This means that if I'm trying to do a process and after the process I need to make an input to my program, I will use an arrow or a line to link the two activities or the two sequence of steps in my program. So once anybody sees the arrow, it knows that wherever this arrow is pointing to is the next action that should be taken in the course of preparing your program code. The uses of these flowcharts. As we have said, they are very useful for programming. The benefits of flowcharts in computer programming process include it is used to document processes in computer program. What are these processes? Like I mentioned earlier, you may have need to make an input, you may have need to send an output, you may have need to display that you needed to take a decision. So the flowchart will help you to document these processes before you start your program coding proper. Two, it makes for better communication of a system to people. I want to present the program to people. My flowchart can easily tell them the steps I adopted in preparing my program. It can also help me to know what segment comes first, so I give my audience a better communication in using my program. Again, it helps to analyze problems in a more effective way. So if I have my flowchart, when you sit down to write a program, sometimes you may not be coordinated to know that this first step goes after this, but your flowchart can help you to sit and analyze that problem. Peradventure, I want to look at a program to help students registration. I need to know that before a student can be registered in Federal Government College Port Harcourt, you will have become a student by virtue of gaining admission into the college. So my flowchart will now help me to analyze the problems in a more effective way, step by step. The flowchart also serves as a good program documentation. Sometimes you pick some programs and you see manuals prepared for you by the owner of the program. What that simply means is he would have done a program documentation using a flowchart step-by-step analysis. So once the document is prepared, it may not just be for the user, it may be for the owner of the program at that same time to know that this was what I did at the point of doing this program coding, and then for future reference too. It also acts as a guide or blueprint during system analysis and program development. What do you do in system analysis? I have a system, students' results being processed manually, and I now want to compute those results using a computer system or to improve the existing digital manner of computing these results. What am I supposed to do? If I have a flowchart, it will help me as a guide during the system analysis to know what was existing in my initial system, what I need to add to the new system, and the things I need to remove from that new system. And when I'm done with that, it is still the same flowchart that will help me in that program development, because the step-by-step sequence of the steps will enable me to write a proper program. So you can see that it is usually good before you start writing your program or coding program in any programming language of your choice, you draft your flow chart. The flow chart can be used for any programming language. It is not program selective because it is done in either good English statements or you make a combination of English and some values. Symbols and their functions, what are they? We have said earlier that the shapes used for flowcharts are referred to as flowchart symbols. We have lots of flowchart symbols, but we want to look at the basic ones. The basic flowchart symbols used in expressing computer operations, processes, and their functions include: one, you have the process or the action. The process or action is represented with a diagram called a rectangle. We all know that the rectangle shape is used to represent a step or process in a program whenever data is manipulated. What do you do when you're manipulating data? It means you are trying to perform some actions or a process on the data. An instance, I have keyed in my students' scores in the computer, and I want the computer to process the scores to give me a total of the student's grade. Now, what I'm doing at that point is a process. What will I use to represent that process in a flowchart is a rectangular shape called process or action. I have another one, decision. What does decision do? Decision is represented in a diagonal, in a diamond shape. The diamond shape indicates a point where the outcome of a decision dictates the next step. Just like what you do in a normal life setting, I need to go to achieve an objective. I have to make a decision whether I should take a step or another. So the same thing happens in your programming when you have a flowchart. The decision shape is a diamond shape, helps you to take a decision either to continue to a step in the program or to take another step, but it forms your decision. We have the terminator represented with an oval shape. This indicates a start or end point of your flow chart. For every program, there is a beginning and there is also an end point in that program. You don't leave any program endless. An example, if I'm computing students' result of college, Federal Government College, Port Harcourt, if I start from the point where a student is registered, I get the student subject, I get the student scores, I get other personal details about the student. The end point is that I have published student results. Once the student gets results, that program to compute students' results has come to an end. So the terminator will show you where it started and where it ended. You have the multiple documents. Multiple documents represent documents in that process. In every program, you have documents that you can get from different environments. It can be the ones within your environment. So those documents that you have are represented using the multiple document shape. You have your data shape. The data shape indicates that information is coming into the process or your program from outside, or it is leaving the process. How do I mean? If I have a program running, that data shape tells me that I have scores to get from either teachers, I have scores to get from maybe other documents where student scores are kept. And once I am done, I have data going, and the data is that I'm giving the students their results. So that data shape tells you there is something going out and there is something coming in at any point in time. Manual inputs. The manual input shape, as you can see, represents a step where a user is prompted to enter data or information manually through a computer console. What does that mean? I want to give information to the computer. If it gets to a point, sometimes you see people who buy forms and they are expected to fill the forms online. They get to a point where the computer requests for an input from the user of the program. Now, this manual input shape is used to show that at that point, a manual input is required from the user. So you, the programmer, knows that when you get to that point, you will prepare a program segment that will allow the user to make an input into your process. We have the on-page connector. The on-page connector, represented with a small circle, indicates that the next or previous step is somewhere else on the flowchart. Let me give you an instance. When you look at your exercises, sometimes you want to write and you're on a page, you are done with that page, and sometime again, the topic on that page continues on another page, which is not the next page. What do? Because you cannot continue, sometimes some of us use what we call PTO, please turn over. Some use other checkness, some use depending on what you want to use for yours. So same thing applies to a flowchart. When a program or step continues on a page and is not exhausted on that segment, it needs to continue on another segment. You will use the on-page connector. Anybody that looks at your flowchart knows that at that point in that program, you need to get to somewhere else to find the continuation of the program. Then we have a document that shows a step that results in a document. When you see your document shape, remember previously we have seen multiple documents. So in this case, when it is one, it shows that you are producing a document from that process. We have another shape, the input to output symbol, that is represented using a parallelogram. A parallelogram represents input or output in a program process. So once I see a parallelogram in a flowchart, it tells me that at that point, an input is needed in that process, or an output is going out from the process. So when I'm doing my coding in that program process, I will know what codes to apply to either get input or to send an output. We've talked about arrows before. Arrows are connectors that show relationships between the representative shapes on a flowchart. What are these connectors? It means that when I have a process running, at every step, whatever I see linked to that arrow shows that the next step is the one linked to that arrow. Okay, so I do hope you will try to do a flowchart for a program process. Let's quickly look at some sample flowchart diagrams. We have one in figure 1 and we have another in figure 2. Figure 1 is used to represent a program for finding lost items. The first shape there is the shape of the terminator, which starts the program. You can see start, the arrow leads you to the next program statement to prepare code that will help you search for lost item. Now, when you're searching for lost item, the arrow goes down to the diamond shape that helps you make a decision if you have found your item. So we prepare a segment that will say, did you find it? If you did find the item, it means you will need to give the system a response yes. When you say yes, it goes down to stop searching. If you give it a no response, it takes you to, do you really need it? Now, this is another diamond shape that brings a decision. So if I need that item that is lost, I must find it. I will give a response of yes. And when I present yes, what happens? The flowchart will enable me to do a segment to take me back to search for lost item. But where I don't need it, it takes me to stop searching, which is the end of the program. So it continues in that circle from start to stop. And when I'm preparing my program segment, these flowchart symbols will guide my coding. You look at this fig 2. The figure 2 is used to represent a program for adding two numbers. From start, you get to read the number A. That means the computer is expecting you. Remember that symbol there shows input, output. The computer is asking for a number. Then it has read number B. It has given room for two numbers to be read or input into the computer. Now, my next program segment will continue to say calculate sum as number A plus number B. And we'll continue. The arrow points further to print sum after doing the arithmetic operation addition. And then when we are done with the output of printing sum, we'll now get to end. You may try to write program codes to search for lost item using the flowchart symbol displayed, and also try to write a program to add two numbers using the segments in the flowchart represented here. Now we'll go further, look at programming languages. In this case, we will look at programming languages using some questions drawn from past basic education certificate examination papers. You will agree with me that programming language is a vast topic. You would have had some parts of it in your junior secondary 1, you had some in junior secondary 2, and some in junior secondary 3. So we'll quickly do a review using the past basic education, your basic examination papers, to review the topic. Now, let's first look at a program. Use the program below to answer questions 1 to 5. From our program segments, the program is meant to find the sum of 3 numbers. Line number 5, this is a basic language program. Line number 5 shows CLS, which will help you to clear the display screen before the program is executed. You have line 10, REM, program to find the sum of 3 numbers. Line 20, read A, B, C. Line 30, data 10, 5, 15. Observe how these variables and values are separated using commas. Line 40, let sum equal to A plus B plus C. Line 50, print sum in quotes equal to sum. and line 60 end. That's the end of the program segment. Now, I want you to observe that in writing this basic program segment, you can use any line number of your choice. You are not restricted to line numbers 5, 10, 20. You can use 2, 4, 6. You can use 3, 6, 9. You can use 1, 2, 3, 4. You can use 15, 17, 19. Just program lines of your choice. Now let's get to our questions. Number 1. The values of variables A, B, C are shown in the number line dash. Look at line 30 where you have data 10, 5, 15. That's where the variables are displayed. So the variables on line number 30. You may ask, what is a variable? In computer programming, we have data types. One of the data types is variable. Another common one is a constant. When it is a variable, it is a data type that can change depending on conditions or on information passed to the program. An instance, if I'm doing students' result computation, I don't expect to put the same score for all students. So I will have different scores for different students, which are now the variables because they can change. But if I'm looking at a constant, if I have a first term result, every student in the school will have first term as that data type. So we're not going to change it because it's a constant. So when it's a constant, it's something that remains, you're not changing it. But a variable is when it changes. So for our line 30, you have variables A, B, C. Number 2, the output of the program will be dash. Take a look at line 50 where you have int. Notice that the sum equal to is represented in quotes. That means when it will be printed as output, it will print sum equal to literally and then give you the other sum as the output. So the output of the program will be sum equal to 30 because our variables values are 10, 5, and 15. So if the values of our variables are 10, 5, 15, the output of the program will be 10 plus 5 plus 15. 3. The number line dash shows the arithmetic operation. The arithmetic operation in this program is the addition because the remark says the program is to find a sum of 3 numbers. So where do we have the arithmetic operation? Look at line 40 that says let sum equal to A plus B plus C. Number 4, which of the following statements is not on the program? If we take a look at our program, A says assignment. Yes, there is an assignment statement in our program. Line 40 is an assignment statement. Let sum equal to A plus B plus C. Line 30 shows us data statements where you have data 10, 5, 15. And line 16 displays the end statement where you have end. And line 50 shows the output using print sum equal to sum. So the only statement that is not in our program is loop statement. Number 5, which of the statement numbers indicates clear the screen? From our program segments, line number 5 shows CLS, which simply means clear the screen. 6. What is the meaning of the basic statement below? In the statement, line 10 reads BAC, while line 20 reads data 251. So what does that tell you? Initially, we had said when you have a read statement, what must follow should be a data statement so the computer can have the values for the variables. So in this case, from our read B, A, C, it means that the value for variable A is 5. The value for variable B is 2. And the value for variable C is 1. Number 7, the basic statement, let X equal to A plus B is A slash and dash. From what we had done initially, I know you can easily answer this. It is an assignment statement. We are assigning variables, values, constants to the program. Number 8, which of these is most oriented to scientific programming? Amongst the list, the most oriented to scientific programming is the Fortran language, which is referred to as formula translation. Fortran is an acronym for the formula translation. We have the basic there, which has to do with object and scientific. We have the COBOL that aligns more to business programs. We have the Java that takes care of most of your object programs, like the games you play. Now, number 9, high-level language was developed in dash generation of computers. The high-level languages are actually the ones written in the human readable form that you and I can understand. So they came into existence when the third generation of computers were developed. So third generation brought about programming languages, programming in high-level language. Number 10, the rules that govern the structure of a command or programming language is called hash. In programming, there are several rules you must apply while writing your program code. Rules like the syntax rules, rules like the logical rules. Now, what is the rule here? The rule that governs the structure of a command. It is the syntax rule. The syntax rule will simply specify the correct sequence of symbols that can be used to form a correct program, or simply put, the grammar rules in your programming language. So that rule that governs that structure of the commands you use is known as your syntax rules. Number 11, beginners all-purpose symbolic instruction code was developed at Dartmouth College by Hash. BASIC, like we all know, is an acronym for the beginners all-purpose symbolic instruction code. From history, it was developed at Dartmouth College by the mathematicians John J. Kemeny and Thomas E. Coles. Number 12, which of the following is a type of program error? We have the options there, but the error there is the logical error. That's the type of program error. Of course, logical errors can be the most difficult to handle when doing a programming coding. Why? Because in the course of doing your program codes, your logic helps you to know when your codes are technically correct or wrong. So if you do the technical thing wrongly, your program will be running, but not as expected. So our documentation is not an error. Symbolic, systematic typing, the program error there is logical error. Number 13, which of the following is an example of a basic keyword? From our options then, we have input. Keywords are usually reserved commands in programming language. So the best option there is input. What is the output of the following program segment? Look at your program segment. You have 10, A equal to 10, line 20, C equal to A asterisk 2, and line 30 in C. This program segment is actually meant to do a multiplication of the number A and 2. So what do you expect as your output? Once you have A asterisk 2, it means 10 times 2 because the value 10 has been assigned to A, then your output print C will give you 20. Number 15, what is the full meaning of basic? Oh, quite a simple one. Beginner's all-purpose symbolic instruction code. Number 16, the command REM in basic programming means that from our previous segments of the program, we have seen that REM is a short form of saying remark. So what does a remark do? It simply tells the user of the program that what operations the program performs. Like the program in number 14 above can have a remark, program to multiply a number. Number 17, which command is used to erase the screen of the computer during the execution of a basic program? The command is CLS, short form for clear screen. What does it do? It clears every segment on the screen of the monitor before your program execution or during the program execution. Number 18, what is the first step in writing a computer program? When you are doing a computer program, you have your problem definition. You must know what problem you intend to solve. Secondly, you will plan a solution. The next step, you will do your program coding. When you are planning your solution, that you can now prepare your flow. Then you have your program coding where you begin to write the program itself in a chosen language. Then you have to test your program. After testing the program to remove bugs and errors, you now do a documentation, like a manual for users and for future reference. So the first step is problem definition. Because if you don't know your problem, if you don't have a problem defined, you cannot write a program. Number 19, name 3 high-level languages you know. There are 1,001 high-level languages. What are these high-level languages? The one you and I can read. They are represented in human readable forms. We have examples like basic language, the Python, the Java, C++, Pascal, COBOL, Fortran, PL1, and so many of them. There are several programs you can adapt when you want to do your program. Then we have number 20. What code is used to represent programming languages in a computer? What do we actually use? If we write programs in human readable form, that's the high level languages. When it gets to the computer, how do we represent it? Remember that we said computers understand information in binary form, which is zeros and ones. So to represent our program codes in computer, it means the computer will be seeing it as zeros and ones. So it will convert every code you have there, 0 and 1 equivalent. I do hope you find time to review these questions on your own again. You have the answers to the review questions for your further studies. So you have number 1 to 20, the answers displayed. You take a look at the questions again and compare the answers that we have here. I hope we've had a very pleasant time. I will not leave you without an assessment. So for our assessment, answer all questions in computer studies from your Laswell Evergreen Solutions textbook. Please submit your work to my email, bettyahiwe2020@gmail.com. You can also send your questions if there's any aspect of these topics that you do not understand. These topics are topics students ignore a lot, but I assure you, if you go through your Evergreen Solution textbook that has the past questions, you will see questions on flowchart and programming languages as much as possible. So I do hope you will do these assignments and submit as required. At this point, I wish to remind you again to always remember that the world believes in you. Be awesome, be yourself, try your best in everything you do. Stay positive, stay at home, stay safe. You are the reason we are here. Bye until I come your way again.